In a large population of patients, 20% have early stage cancer, 10% have advanced stage cancer, 70% do not have cancer. 6 patients from this population are selected. Calculate the expected number of selected patients with advanced stage cancer, given that at least one has early stage cancer. So let A be the number of patients with advanced stage cancer and X be the number of patients with early stage cancer. So we're not calling the early stage patients as E because E is also a symbol for the expected value. Therefore, we're calling that X, but A has no other meaning. Therefore, advanced stage patients would be A. So since we have to find the expected number of advanced patients given that at least one is early, which means we have to find expected value of A given at least one is early, which means A given X is greater than or equal to 1, because at least one early means X is greater than or equal to 1. X was the number of early patients. Now, the formula that is going to be used here is this, that expected value of A is equal to summation of probability X equals K times the expected value of A given X equals K. So the expected value of any variable can be broken into a sum like this. So here, when we have K equal to 0, we will have probability X equal to 0 times E of A given X equal to 0, and so on. You sum it like, so whatever we have written for X equal to 0, then you keep on adding such terms for X equals 1, 2, 3, 4. Here I have lumped together all these terms for 1, 2, 3, 4, and so on, because greater than or equal to 1 includes all of those. And we did it like this because this is what we have to find, expected value of A given X is greater than or equal to 1. That's why we wrote it in this form. So now from this equation, we can find the expected value of A given X is greater than or equal to 1 by doing the algebra. So first we subtract this term from the EA. So we get EA minus this term, Px equal to 0 times EA given X equal to 0. And after the subtraction, we have this factor left over, probability X greater than or equal to 1. We divide by that. So and by algebra, we get this expression for expected value of A given X is greater than or equal to 1 from this equation. And now what we will do is we will one by one find all the values on the right hand side. So there are 4 of them. There is this term E of A, then there is P of X equal to 0, then there is E of A given X equal to 0, and then we have the denominator, probability X greater than or equal to 1. So we first find the denominator. We find probability X greater than or equal to 1. In fact, on the way of finding probability X greater than or equal to 1, we will also find probability X equal to 0, which is this term in the numerator. So now, remember, X was the number of early stage patients, and that is binomial. So we can even say here the number of patients with early stage cancer, comma, let's say that this is X. X is binomial with n equal to 6. And n equal to 6 and p is equal to 0.2. And therefore, the probability that no patient has early stage cancer is probability x equal to 0, and that will be 6c0 0.2 power 0. And the reason n is equal to 6 is that we are told that we are selecting 6 patients and p equals 0.2 because the probability of someone having early stage cancer is 0.2. That was given to us in the problem. 20% early stage cancer. It's by the basic binomial formula, ncx p power x 1 minus p power n minus x. We have the probability x equal to 0 equals 6c0 0.2 power 0 1 minus 0.2 power 6 minus 0. That comes out to be 0.262144. And then the probability at least one has early stage cancer is the complement of no one has early stage cancer, not E, but X. So it's the complement of 0.262144, and that's 0.737856. So at this point, we have found this denominator to be 0.737856, and we have found this expression in the numerator. The P of x equal to 0 is this one. So now we are left with E of A and E of A given x equal to 0. So to find E of A, we know that A is also binomial. A is the number of patients having advanced stage cancer. Let's say that this is A. Is binomial, and that here again n equals to 6 because 6 patients are selected, and p is 0.1 because we are given that 10% patients are advanced stage cancer. So we know the expected value of binomial is np, so it'll be 6 times 0.1 equals 0.6. So now we have this term as well, and all we are left with is the E of A given x equal to 0. So let's understand what A given x equal to 0 is. So A given x equal to 0 is the number of advanced patients given that there are no early stage patients, number of advanced stage patients given that there are no early stage patients among the 6 chosen ones. So this is also binomial because if we are given that there are no early stage patients, then a patient could be advanced or not advanced. So that's a binomial situation. So let's, we know that n is equal to 6. We have to do some work to find what the little p is, the probability of success, which in this case is the probability of a patient being advanced given that the patient is not early. So probability of advanced given not early, because we are given that early stage patients are 0. So no patient could be early. So advanced given not early by our basic formula would be advanced and not early divided by not early. So advanced and not early is just advanced because you don't even have to say not early. If somebody is advanced, then that means not early. So advanced and not early is just the probability of advanced, which is 0.1. And not early will be 1 minus the probability of being early. So that comes out to be 1 over 8. So now, as we said, that A given x equal to 0 is binomial. We already knew that n is 6, and now we have calculated that the little p here is 1 over 8. And therefore, the expected value of A given x equal to 0 is the binomial formula for expected value, NP equals 6 times 1 over 8 equals 0.75. And now we have everything on the right side. And on the right side of 1, as we've been pointing out, this, and this. We have all the 4 things. The denominator is this one, 0.737856. E of A we just found, not just found, but we found it early, it was 0.6. P of x equal to 0 was 0.262144, and E of A given x equal to 0 is the last thing we found, the 0.75. So when we substitute all these in this, we end up with 0.547. That was choice C.